Hello everybody, welcome to Unit 9, which is going to be molar conversions. This unit is kind of a potpourri of stuff. It's a lot of math, it's a lot of calculations, but within this unit we're going to learn some simple ones, some complex ones. We're going to review some things we've done before, we're going to add new pieces to the puzzle. All sorts of stuff is kind of going on. So like many of the other videos, I'm going to try to kind of stick with your PowerPoint just so you kind of get an idea of where we're going. It's a great thing to have handy if you go ahead and go online and print out that PowerPoint. So let's start at the beginning here. Chemistry issue. How do we measure how much of something we have? I mean, one of the big things we always want to know in chemistry is how much reactant, how much product. So there's a couple ways we can do that. One of the ways that we do a lot of, which you know, is we can measure mass. Mass is in grams. Mass tells us how much stuff we have, how much it's made of. We can also, as you know, look at volume. Typical unit of volume is liters, and then all the metric equivalents, milliliters, kiloliters, deciliters, things like that. That tells us how much space the stuff occupies. The third way we can figure out how much stuff we have is we can count the pieces. Okay, how many pieces do I have? How many particles do I have? So actually, how many little parts? The issue with that is most of our samples have a lot of pieces, okay? And I mean a lot of pieces. If you can see it with your naked eye, I mean, you're talking 10 to the something going on. And we don't want things to constantly be in scientific notation. We want them to be simple. So as scientists are looking at how do we count these pieces, they decided, let's keep it simple, let's create a new unit. And we learned about this new unit earlier this year. The new unit is the mole. Dun, dun, dun. So what is a mole? A mole is defined as, and this is on the PowerPoint, the number of carbon atoms and exactly 12 grams of carbon-12. That's a whole lot of information, but how many atoms are in 12 moles of carbon-12? So or 12 grams, excuse me. It is a made-up measurement. This is not a thing where, we said, oh my gosh, it's been around forever. No, scientists created this in order to make everything easier. And when we're talking about a mole, we talk about Avogadro's number. Avogadro, of course, is a scientist that gets credit for this, but Avogadro's number is how many particles are there in 1 mole of a substance. And as we learned earlier this year, Avogadro's number is 6.022 times 10 to the 23rd. So the comparison I always use is a dozen. If you have a dozen tables, you have 12. If you have a dozen calculators, you have 12. If you have a dozen bags of Cool Ranch Doritos, share them with me, but before you do that, you'll have 12. Well, if you have 1 mole of anything, it doesn't matter what it is, you will have 6.022 times 10 to the 23rd. That number could be in pieces. That number could be in particles. Okay, so sometimes it'll be written as 6.022 times 10 to the 23rd atoms. It could be molecules. It could be a fancy term called formula units. So there's all sorts of different ways to express it, but it's all the same idea. So what do we do with Avogadro's number? Of course, we do conversions. So I may ask you 0.3 moles of something, okay, and we'll just say fluorine, is equal to how many atoms? This is a simple one-step conversion. Just like before, given is always up here on your top left. You always carry your unit down to here, and then your unit that you're looking for is going up top. That pattern stays around forever. And then we go to our conversion factor from the last screen. 1 mole is 6.022 times 10 to the 23rd atoms. Okay, very straightforward, very simple conversion. And that's really it. That's all we're looking at with a mole. Easy. So the other thing we want to talk about today is something called molar mass. Molar mass is exactly what it sounds like. It's the mass of 1 mole. Ha-ha. Okay, and so your units are going to be grams per mole. How many grams are there per mole? We know 1 mole, always going to be 6.022 times 10 to the 23rd pieces, particles, atoms, molecules, whatever. Okay, but you got to remember those pieces can have different masses. For example, and this is about to get funny because y'all know I can't draw. Let's say this is me. Yay, I'm happy. Look at me go. Okay, in this hand right here, and I swear there's a hand. Wait, there's a hand. Oh dear Lord, that's bad. Anyway, in that hand, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 eggs. Okay, that's what I have in that hand. In this hand over here, which is not much better. I don't know what's up with that little finger right there. That's just weird. But anyway, in that hand, I have 12 elephants. Okay, so you can imagine, you know, elephant. There's his butt and his little tail that I'm holding. Okay, and there's one leg, and there's another leg, and there's like a big old belly hanging, and his head's not even on the screen. So we're going to say I have 12 elephants. It's actually not a bad back end if you give me credit. So there's 12 of those, there's 12 of those. It's exactly the same number of particles, but the masses are not the same. Obviously, the 12 elephants are a heck of a lot more mass than those 12 eggs. So when we talk about molar mass, sometimes you'll hear it called formula mass. It's the same idea, but it is going to be different for different substances. Okay, so even though it's the same number of particles, it's different for different substances. So where do we find it? If you remember from before, molar mass is found on the periodic table. Yay! Okay, so this is exactly what you did before. The way we wrote it out earlier this semester is we said 1 mole is equal to the number of grams off the periodic table. Easy. If it's a compound, you add the parts. So like if you had H2O, you would say H is 1, the second H is 1, the O is 16, the mass is 18. And that allows us to now have two conversion factors. We have 1 mole is equal to the number of grams off the periodic table grams, and we know that 1 mole is equal to 6.022 times 10 to the 23rd, atoms, pieces, particles, molecules, whatever. So y'all know enough about math. If 1 mole is equal to this, and 1 mole is equal to this, then that means these two are also equal to each other. So sometimes it is easier to write this as like one big strand. So 1 mole is equal to the periodic table grams, which is equal to 6.022 times 10 to the 23rd. And that's atoms, pieces, particles, molecules, whatever. So you can use this for conversion factors. And again, this is all review, okay? And so you can always go back to the prior unit if you need a little bit more. But if you're doing a conversion, sometimes they're very, very simple. So 3.5 moles of copper is equal to how many grams of copper? Nice and easy. 3.5 moles up here, carry my moles down there so that they cancel. Grams is here. 1 mole is equal to the number of grams off the periodic table, which happens to be 63.55. Easy. Little more complicated, but still not bad, is what if you have 5.69 grams of NaOH, and I want to know how many molecules that is. Okay, now there's a couple ways you can set this up. You can do this as a two-step cross, but if you're not a fan of two-steppers, watch. Put your given up there, put the unit of your given down here, put the unit you're looking for there. And just like we did before, what do we fill into molecules and grams? So if I go back a slide, check out what I wrote right here. Okay, 1 mole is equal to the P table grams is equal to 6.022 times 10 to the 23rd particles. So here, I have molecules in grams. Well, grams is off the periodic table. Sodium's 23, oxygen is 16, hydrogen is 1, so that's 40. And then my molecules is my 6.022 times 10 to the 23rd. There's nothing wrong with keeping it that simple. That is a great plan. Okay, it is perfectly acceptable if you like the longer version. Okay, to actually set it up as a kind of a two-stepper. 5.69 grams, grams would be here, and you'd go to moles first, and then moles to molecules. But if you look at it mathematically, that and that are both 1, so it's exactly the same thing. Literally, the setup is totally up to you. It's whatever you are finding more comfortable. That's it for today. Come back next video. We'll talk about gases, molar volume, STP, and density.